morning. In this session, we are going to discuss some MATLAB programs in digital signal processing. The first one is the program how to generate a step signal. To generate a step signal or to write any program, first of all, we have to use two commands, close all and clear all. In this close all function is used to force the or close all the figures that are running, and clear all command is used to remove all the variable global functions that are in the running process. So basically, close all and clear all remove all the figures, variables, functions that are in running. And the next step is to n equal to minus 10 to 10. This step is given to represent the duration of the x-axis. Here, when looking into the figure of the step signal, this is the output of this program. Here we can say this is the figure of a step signal. Here in x-axis, the duration is from minus 10 to 10. And step signal means, or unit step signal means, it has an amplitude of 1, and for a positive unit step signal, its amplitude or its unit amplitude are from 0 to here x is in x-axis, the limit of the positive x-axis is represented as 10. So here the amplitude 1 will be from 0 to 10. So in x-axis minus 10 to 10 is the limit. So we have to draw the figure of unit amplitude from 0 to 10 only, and from 0 to minus 10 the amplitude will be 0. So to plot that figure, we have to write a for loop. For I equal to 1 to length of n. Length of n means length of the duration, means length of the x-axis. How long we have to plot the step signal, that means the length of the signal. For I equal to 1 to length of n, if n of I greater than or equal to 0, x of I equal to 1. We know for a unit step signal in the positive axis, its amplitude will be 1. So similarly, if n of I greater than or equal to 0, x of I equal to 1, else x of I equal to 0 and 2. Here next function is chum n comma x. Here x chum of n x means we have to plot that in chum form, means not in continuous form. Here we are plotting the figure in the discrete form. That's why we are giving the function as chum of n x. To represent the x label and y label. Here x label as time index. We can see in x-axis we mark the x-axis as a time index, and for y-axis amplitude is represented. And to name this figure, we can give the title as unit step wave. And one more function is given as grid. The grid is given to represent the graph to bold the grid formats, means here we can see all the grids are represented in darker lines, that to represent the graph in grid format. This is the program. This is a basic program to represent or to plot a step signal in discrete format. And next program is the impulse signal. Impulse signal. How to generate an impulse signal? We know an impulse signal is a signal that has value only in the zeroth position. Here in the figure or in the output of this program, we have the value only in the zeroth position. In zeroth position, its amplitude is 1. Remaining all positions, amplitude is 0. So to plot an impulse waveform, as usual, we have to close all or clear all the functions and to mark the x-axis, in x-axis n values. Here we are plotting in discrete format, that why we are representing as n equal to minus 10 to 10. Minus 10 to 10 is the limit of the x-axis. For I equal to 1 to length of n, if n of I equal to 0, x of I equal to 1, else x of I equal to 0. If the value of n equal to 0 only, then the x of I equal to 1. Remaining all positions, the x of I will be 0. That will be the that is how we plot the unit impulse signal. And unit impulse signal means its amplitude in the 0th position will be 1. And stem of nx, as I mentioned earlier, stem of nx is to plot in discrete format, and x label is given to represent the x-axis as time index, and to represent the y label is given as amplitude, then title as unit impulse wave, and finally the grid function to represent the grid in the output figure. Then next program is how to generate a square wave. To generate a square wave, first of all we write close or clear all command, then plot the t means time index, t equal to 0 to 0.001 to 1. This is the way how to represent the time index. Then f equal to 3 is the frequency of the square wave, and duty equal to 50. Here just given a value 3 or 50. 50 means duty cycle of 50. And a equal to square of 2 pi f into t comma duty. This is a function to generate a square wave or to plot a square wave. If you place the cursor in the square of this function a equal to square of 2 pi ft into duty and make a right click on this position, you can get a help window from the MATLAB software. They give in detail how the square function work. Then next step is the plot t comma a. Plot t comma a represent or it plot the figure, output figure. Then x-axis 0, 1, minus 2. It represent x-axis and y-axis. 0 to 1 represent the x-axis and minus 2 to represent the y-axis. And as mentioned earlier, x label, y label, title and grid on is given to represent the figures and the graph. Then next program is how to generate a ramp wave. We all know the ramp signal. To write the program, first we do close all, clear all the function, and then represent the axis n from 0 to 10. For I equal to 1 to length of n, if n of I greater than or equal to 0, x of I equal to n of I. X of I equal to n of I means x of 0 equal to n of 0. X of 1 equal to n of 1. In that way. Else n of I equal to 0 and stem of nx means to plot them in discrete format and then given x label, y label, title, grade as we do in the previous programs. Next program is how to generate a sine wave in discrete format. For that, first of all we clear all and close all the hidden files and programs and figures. Then give the frequency of the sine wave. Here given the frequency of the sine waves as f equal to 2 and t equal to 0 to 0.01 to 1. Here in x-axis time index is represented and its limit is 0 to 1, and in the limit of 0 to 1 there will be 1 by 100. 0.01 means 1 by 100. That means 100 samples are represented in between the 0 to 1 limit. And here given the amplitude of the sine wave as a equal to 10. By using these informations, we are going to plot a sine wave by using the function x equal to a into sine 2 pi ft. And then stem t comma x means stem or plot the sine wave in stem format in t comma x means t and x are plotted. T in x axis and x means in the amplitude of the wave. And then grid to represent the graph in grid format, and x label, y label and title as we said before in before programs. And next program is to how to generate or how to done an amplitude modulation, or how to perform the amplitude modulation using two waves. For amplitude modulation, we have carrier signal and a modulating signal or message signal. By using these two signals, we perform the amplitude modulation and we get the amplitude modulated signal, which is the output of the amplitude modulation. To perform the amplitude modulation or to write the program, first of all, we write the close all and clear all commands. In the x-axis or in the time index, we are going to represent t from the limit 0 to 1, and in between them 0.0001 means 1 by 10,000 values are in between the 0 to 1. Here we are given the modulating signal frequency as 5, fm equal to 5 and fc equal to 50. Fc means the carrier frequency, the frequency of the carrier signal. To generate the modulating signal, x equal to sine 2 pi fmt is the function here we are using. And here we are seeing a new function subplot 131. Subplot means here we are plotting three waveforms. 131 means first one indicate the number of rows, and middle three represent the number of columns or number of figures, sub figures you are plotting in. And first and 131 last one indicates the position of the figure. Subplot 131 means in among three figure, here you are plotting or here you are representing the modulating signal as the first figure. Then plot t comma x. Plot t comma x means plotting the modulating signal, and grid here labeling in x position, y position and title is given. And in this y equal to sine 2 pi fct, here you are drawing the carrier signal. And subplot 132 means among three figures, here two carrier signal are plotted in the second position. And plot t comma y, here we are plotting the signal. And then grid. In these are the figures we are plotting by using this program. Here in the first one is the message signal, means modulating signal, and the second one is the carrier signal, and third one is the modulated signal. A equal to 1 plus x dot into y. This means the amplitude modulations are performed using this equation 1 plus x dot. Dot means here we are performing the matrix multiplication. If we forget to place the dot, then we didn't get the output or we didn't get the amplitude modulated signal. So amplitude modulation will perform only when we place the dot symbol in this equation. So to perform the amplitude modulation, the function or the equation is to a equal to 1 plus x dot into y. Then for plotting the amplitude modulated signal, we use the function subplot 133. Last three means here we are plotting the amplitude modulated signal as the third figure. And then plot t comma a and grid, and the remaining x label, y label, title are you are to represent the figures. Here these are the output waveform we get after running this program. And first one is the message signal or modulating signal, and second one is the carrier signal, and last one or third signal is the modulated signal. Next one is the linear convolution. How to perform the linear convolution among the two values. Here we have given two values x1 and x2. In x1 1, 2, 3, 4 are the input values, and in x2 5, 6, 7, 8 are the input values. To perform the linear convolution among 1, 2, 3, 4, 5, 6, 7, 8, we have the function. We have the inbuilt function in MATLAB. Here the function to perform the linear convolution is f equal to c or nb, means convolution of x1 comma x2, and L equal to length of f minus 1, which means n minus 1 samples n. Here we know n is the number of samples after the convolutions. Here L represent the n minus 1 samples. So to find the n, we are taking the length of f. So f equal to convolution of x1 comma x2 and L equal to length of f minus 1. To represent the x-axis, we are representing n equal to 0, 1 to length L. Then display output sequence f. Here we are placing f. That means the output or linear convoluted values are displayed on our command window. To display the output sequence in command window, we place the f in this way. Then stem of n comma f and grid. Stem of n comma f plotted the stem in graphically, and grid and x label y label title are given to this graph, and this is the linear convoluted signal. Next one is the circular convolution. To perform the circular convolution among two values, means x1 and x2. Here x1 consists of 1, 2, 3 values and x2 consists of 4, 5, 6, 7. In theory, we studied that to perform the circular convolution, the length of the samples must be equal. Here, the number of samples in or the length of samples are different. Number of samples in x1 is 3 and number of samples in x2 equal to 4. To make these samples equal, we append the zeros or we added zeros to x1. Then x1 and x2 become equal. Then n1 is the length of x1 and n2 is the length of x2. Small n is the maximum of n1 comma n2, which means maximum of n1 comma n2 means the length of here we are taking maximum length of n1 or n2. Here we are the maximum length is for x2. That means the n2 is the length of x2. Then n equal to maximum of n1, n2. Then n will got the value of n2. Then x1 equal to x1 zeros of 1 comma n minus n1 and x2 equal to x2 zeros of 1 comma n minus n2. These two functions are given to append the zeros to x1 and x2. This to make the x1 and x2 for the circular convolution. x1 and x2 equal for performing the circular convolution, and the circular convolutions are performing by using the function y equal to c or n, means circular convolution of x1 comma x2 comma n. To display the output sequence, we place y label as in this program. Here we can see in the command window on the right side output sequence y equal to 36, 34, 28, 34. This is the output value that we got after performing the circular convolution among the values of 1, 2, 3, 4, 5, 6, 7. To plot these values in graphically, we can represent or we can give the function as term of y in grid format. And next is the DFT. To perform DFT, as usual, we write closure and clear all function to clear or close all the figures or command windows that are in hidden. Then %DFT of input sequence is in hidden command. On writing this equation after the percentage symbol, this will show in the green color. This is only to represent or only to for the information of the programmer. And next, x1 equal to 1, 2, 3, 0 is the input values. On this value, we have to find the discrete Fourier transform. The length of the input signal is 4. That means n equal to 4. To find the discrete Fourier transform, we have the input inbuilt function in MATLAB, x2 equal to f of t of x1 divided by n. To plot this x2, we are using subplot 2 to 1. Here 2 to 1 represent, we have 2 rows, 2 columns. Among 2 rows, 2 columns means 2 in this figure. In this way we are going to plot. Here you can see 2 rows and 2 columns are represented. In 2 rows, 2 columns. That means in first row, the first figure, and first row, second figure, second row, third figure, and in second row, fourth figure. And to plot as the first figure, we are going to represent in the format as subplot 2 to 1. Here L equal to 0 to 1 to length of x2 minus 1, and stem L comma absolute of x2 means here we are plotting the absolute value, means magnitude of the DFT are plotting in the first graph, and it is represented in grid format, and title display x2 is given to display the x2 values in command window. Subplot 2 to 2 to represent the DFT angle format. To represent the angle of DFT, stem of L comma angle x2 function is used, and then grid title to given the figure. Then third one is the ID of T of output sequence. To find the inverse discrete Fourier transform of the output sequence, we have the inbuilt MATLAB function if of t of x2 dot into n. Subplot 2 to 3 is third figure is the angle of inverse discrete Fourier transform of the output sequence, and grid title is given for to represent the figure, and display input sequence are used to represent this input sequence x3 in the command window. Subplot 2 to 4 function is used to represent the fourth figure as the angle of the input sequence. Here x3 is the input sequence. After taking the inverse discrete Fourier transform of the output sequence, we get the input sequence. To represent the angle of the input sequence, we can represent it as sum of L comma angle x3, and for the figure we are using grid and title. This is the output after running this program we will get. The first figure represents the discrete Fourier transform, magnitude response of the discrete Fourier transform of the input sequence, and the second figure is the angle of the discrete Fourier transform, and third one is the inverse discrete Fourier transform, and fourth one is the angle of the input sequence, means inverse discrete Fourier transform of the output sequence. These are the programs we are discussed in this video session. Thank you.